are going to discuss another lab experiment. So it is experiment number 4. It is performing the task of solving a given difference equation. Okay. So how to perform this solving a given difference equation using MATLAB. So let us begin with the concept. Obviously, we deal with the initial 3 statements: clear CLC, clear, then clear all, then we have close all. The 3 statements: CLC, clear all, and close all. Then if I want to display on the screen any message, we are going to use disp function. So disp solving a given difference equation. Okay. Obviously, the difference equation, it is such that y of n is equals to, okay, or you may go for y of n plus a into coefficients of y with delays, okay, which is equals to the sum of all input signals x of n with previous values of x of n with its coefficient. Okay. So as you know what is the difference equation, so I am not going to tell you how the difference equation, we are directly going for what is its solution by using MATLAB. So here we need these values. So what are the value? The first value we are reading, it is b is equals to input enter coefficients of x of n in order x of n, x of n minus 1 is each previous or delayed version of input signal, x of n minus 1, x of n minus 2, and up to go on x of n minus capital M. Okay. So this is the input signal what we are going to use. So we need to enter the coefficients of x of n. Those are b elements for each x of n. Okay. So let me give the value of b in the form of, let me use only 3 elements of x of n, that is x of n minus 1, and x of n minus 2. So those are 1, then 0, then 0. Okay, let me give the values 1, 0, and 0. So we have got what is b. Okay. Similarly, read the coefficients of output signal, that is a elements. Input enter coefficients of x of n in order, sorry, it is y of n in order y1, y of n minus 1, y of n minus 2 up to y of n minus capital N. Okay. Enter coefficients of y of n in order y1, y of n minus 1, n minus 2 up to n minus capital N. So let me give the values. So I am going to give these fractional values. That is 1 comma first element, then second coefficient is minus 3 by 2, and third coefficient is 1 by 2. Okay, I got a coefficients and b coefficients. Okay, then let me read the conditions for y of minus 1, minus 2, minus 3 up to y of minus n. Okay, so we need to give the, according to this, while solving this the difference equation, you come to know we need initial conditions of y of minus 1, minus 2, and so on, so that we can easily calculate what is y of n output. Okay, so if I read initial conditions of y, then the initial conditions I'm going to set, it is only for two elements. Okay, for two elements it is 4, 10. Okay, so means we are dealing with only two delays in the output and three delays in the input. So it is 4 and 10. Then we need to perform how many calculations we need to sample. Then n is equals to input, enter number of samples to be calculated. Okay, number of samples to be calculated, that is n value. So n I am going to write as 3. Okay, 3 samples I need to calculate. Then we are going to deal with the solving of this one with respect to natural response and forced response and complete response. Here we have standard statements to perform each calculation. So here we need to solve that one by using this function, the solving of this one, difference equation for the given values of a coefficients, b coefficients and initial conditions of y and number of samples to be calculated. It is, we are going to use the standard function, it is FILTIC function with b coefficients, a coefficients and initial conditions. So we have calculated. Then we need to go for the x ranges. X we have zeros from 1 to n. Okay, 1 to n we have. So we got x values as 0 to 0. Okay, all zeros from the range 1, n. Okay. Then we have the n range for calculation because it is y of n and x of n. So n ranges from 0 to n minus 1. In each step size is 1 value. Okay, it is incremented by 1 value. So n we got, it is ranging from 0 to 2. Okay, means 0, 1, 2. 3 samples we need to calculate. Then to perform the calculation of this natural response, forced response and complete response, we need to deal with these functions. So let me display what is the process it is going to be carried out next. It is natural response, which is given by y of n equal to filter task. To perform the natural response, it is filter task with b coefficient, a coefficient and x range with respect to the difference equation, that is z. So what we are going to get, the 3 calculated samples are 1, minus 0.5 and minus 1.25. Then let me put the graph of this signal y of n. So go for, I need to draw 3 diagrams. Okay, natural response, forced response and complete response. So let me draw first one. 3 diagrams I am going to draw, column by column. Okay, one below another, and it is first one what we are drawing now. So it is discrete value. So we need to use stem function. Stem n, yn. So what is the n? It is ranging from 0 to 2. Okay, so I need to put all the 3 calculated values on the graph. So you can observe here, yes, we have drawn the values. Okay, it is 1 minus 0.5 minus 1.25. 1.25. Okay. Next, we need to put the labels on the graph. The labels are x label is n, y label is amplitude, and the title is natural response. Okay, you can observe here. Yes, labels are added. Next, we need to add the samples of x. We need to add samples of x, and those samples, what I am going to add, enter n number of x of n values. X of n values. So I need to enter, here it is, x of 0 is 1, x of n minus 1 is 0.5, x of n minus 2 is 0.0625. Okay. Then we need to go for next calculation, it is forced response. Okay. So the calculation is going to begin with the statement, the next process is forced response. That is done by only with filtering YF. Okay, YF is a forced response dealing with B coefficient, A coefficient, and the X values. Okay, X values are 1.25 and 0.625. So by performing that one, the answer will be, the forced response of that difference equation will be 1.75 and 2.1875. Let me draw those things in a graph. The output y, it is subplot 3. So we are drawing 3 graphs one by one, and it is second one what we are going to draw next. Okay. So once again, it is a discrete value. We are going to use stem function for n values. We need to draw YF, forced output. So it will be whatever the values we got, same thing will be displayed in the graph. Next, put the labels. It is x label n, y label is the amplitude, and the title is forced response. Then the last task with respect to this solving this difference equation, it is total complete response. It is sum of both forced response plus natural response. Okay, which is given by the complete response, which is given by the sum of both responses. Yn natural response, Yf forced response. Okay, if we perform addition of these two, it is going to give the total complete response of the difference equation is y of n 2, y of n minus 1 is 1.25, and y of n minus 2 is 0.9375. Okay, let me put this graph. So among 3 graphs, I am drawing third one now. I need to put the graph for n elements, that is YC, complete response YC. Yes, you can observe all values are put on the graph. Then put the labels. Okay. Labels are x is n, y is the amplitude, and title is complete response. Okay. So this is the concept regarding how we are going to solve a given difference equation. Here in the difference equation, the y iterations are 2 and x iterations are 3. Okay. So this one is a simple program what we have executed. Or if you go for any different, you can go through the mathematical book and go for the difference equation for various length. Okay. Let me share another program. Okay. So about it is a ninth program. Okay, what it is belongs to, it is not on MATLAB by using MATLAB only, but here you have to do that one using hardware. Okay, those are comes under hardware part. But let me give the introduction about how the same DFT calculation is going to happen with respect to C program using C program. Okay, the linear convolution of two sequences. Okay, the linear convolution of two sequences. How we need to perform. So the program is using C code. Okay, what we have done. So how to perform this on linear convolution? It is directly the conv. Okay, it is conv function in the conv function in what? MATLAB. Okay, so how we can write same thing in C code? So let us begin. We know the standard statement is the adding, introducing the header file hash include stdio.h. So this is the standard input and output header file what we are going to use normally with respect to C programming. Then we need to declare global variable. Okay, here I have declared a global array. Okay, array with the array name y. So 20 elements array, it is declared globally. So it is void main. Okay, I think if you are using void main. The meaning of this one is what? So void main means you are returning nothing, okay, nothing from this program. Then we have, so what we need to do here, we need to perform linear convolution. Okay, so here what we need to deal with, it is the final answer is what? The linear convolution is what? Summation of n is equal to 0 to capital N minus 1. It is x of n into h of n minus m, isn't it? So same thing we need to perform here, the linear convolution. So let us begin with the initialization step. We need to declare some variables which are required in future in the program. Okay, here I have declared j, n, m, l. Okay, then we have two sequences x and h. Okay, input signal and the impulse response of the system, x and h, with as an array. Okay, as an array we have declared with minimum array elements 20 and 20. So print, enter the length of x of n. So what we need to do here, printf, enter the length of x of n, that is m. Okay, we know in the linear convolution the length of x is m and the length of the h of n is l. So total length of the output signal, that is y, is nothing but what? L plus m minus 1. L plus m minus 1. In the theory we learned that one. Then we need to scan the read by using the scanf function, scanf percentage d ampersand of m. So we have read the length of x of n in the variable m, capital M. Then enter x values. So we know the length of m, okay, length of x of n. So we need to read those many elements by using this statement for n is equal to 0 up to m, and each element is by 1 by 1 element, that is n plus n plus plus. So scanf percentage d, it is ampersand of x of n. So we are going to read m number of elements as x input signal. Then similarly, the impulse response we need to read enter length of h of n, that is L is equals to. Okay, so the length of L will be read by using this scanf function, scanf percentage d ampersand of L. Then we need to read the respective signal by mentioning the statement printf enter x of n. Okay, so on the screen it is going to appear enter x of n. So h of n we need to give ranging from 0 to L minus 1, because the length of that h of n is limited to L elements. So we need to begin from 0. So it is n less than L, n plus plus. So scanf percentage d h of n. So we have read the values of two signals, x of n, h of n, and the respective length. Okay, then perform the calculation, and we know the calculation step, it is what? The total length of the signal is what? Output signal is L plus m minus 1. L plus m minus 1. So we need to go for, so y is ranging from y of 0, y of 1, y of 2 up to y of L plus m minus 1. Therefore, we need to have this equation for loop. N is equal to 0. It is beginning from 0th element. Then it is going to move up to have a loop up to L plus m minus 1 and n plus plus. Initial value, because it is a summation. Okay. So initial value y of n is equal to 0. So y of n, initial step is what? N is equal to 0. Okay. N is a 0 now. If you consider n is 0, so y of 0 is initial value is 0. Then we need to put that one in the equation. Okay. So j ranges from, we have a modulo of n, isn't it? So therefore it is j is equal to 0 to j less than or equal to n, j plus plus. Okay. So it will be circularly shifted. Okay, circularly shifted h of n. Okay, so it is h of n minus j, where j ranges from 0 to n. Okay, so y of n, it is summation of all the things. So y of n plus equals to y of n x of j into h of n minus j. So we have calculated the overall equation by using C program. Then printf linear convolution, the answers will be printed line one by one. That is n is equal to 0 to n less than L plus m minus 1, n plus plus. So printf each element of y, that is percentage d slash n. Slash n means one by one you are going to observe. Okay. Now it is a single string. It is one by one. Line by line you are going to get the elements of y of n. So output will be 1. So once you run this program, you are going to get these statements. So enter the length of x of n. So here I have given 4. Enter the input signal 1, 2, 3, 4. Then enter the length of h of n, that is L equal to 4. I have given. Then enter its h of n signal, impulse response in the system. It is once again, you can give any random number. Okay, any signal element value. Here once again I have given 1, 2, 3, 4. So the linear convolution of this one is 1, 4, 10, 20, 25, 24 and 16. Okay, once you run this one in the hardware component in the lab. Okay, so on the screen you are going to get this answer 1, 4, 10, 20, 24 and 25, 24 and 16 as the answer. Okay. So this hardware execution, it depends on when the circulation given by the VTU, how the lab hardware will be done. So software we can do, okay, by using ONNET Octave platform. But for your knowledge purpose, the program is how we can write the linear, how we can perform linear convolution by using C code. This is the example. Okay. So today we are going to end today's session by explaining these two programs. So in the next class, means on Saturday, I think we covered almost how many programs with respect to lab. We covered almost the first one is over, second one is over, third one is over, fourth one is over, fifth is over, sixth is over. Okay, so 6 experiments in the software part we covered and one program from hardware part. Okay, so in software part only 2 are left with 7 and 8. So those things you are going to understand after covering next module in the syllabus. So once I cover that model, you can easily understand what is happening in the program. Okay, so we'll discuss those things in the next class.